welcome back to Mtali TV. My name is Robert Mtali and I'll be your pure physics tutor. Alright, so in today's lesson we're going to learn the full topic light. Then at the end of the video we're going to have an exam practice where we answer one question on light from the past paper. So make sure you stick around up to the end of the video so that you don't miss the exam practice. Alright, so let's start. So an important property of light is that it travels in a straight line, and there are only two ways its direction can be changed: through refraction or through refraction. So let's look at each of these in turn, starting with the refraction. So refraction, by definition of light, happens when a light from the source reaches the surface of an object and bounces off it before entering our eyes, which is the reason we are able to see that object. So this bouncing happens in a very regular, predictable way on a polished surface such as mirrors. Alright, to talk about refraction properly, we need a few key terms. So a medium is a substance. We need to define what a medium is. So a medium is a substance through which light moves, such as air, water, or glass. Then we need to define what a ray is. So a ray is a path followed by light. Also need to define what a beam is. So a beam is a group of light rays traveling together. So the normal is a line drawn at right angles to the reflected surface at the point where the ray strikes it, and the normal ray is simply a ray of light that passes directly along that normal. So the point of incidence is the exact point where the ray strikes the reflecting surface. So the incident ray is simply the path followed by the light before it strikes that surface, while the reflected ray is simply the path followed by light after it bounces off. So the angle of incidence is the angle between the incident ray and the normal, and the angle of refraction is simply the angle between the reflected ray and the normal. So these angles are governed by laws of refraction. So the first law states that the angle of incidence is equal to the angle of refraction. The second law states that the incident ray, the refracted ray, and the normal ray all lie in the same plane. Now let's look at the image formed in plane mirror. So this is called the virtual image, meaning an image that cannot be formed on the screen, which is exactly the kind of image you see of yourself in a mirror. So a virtual image can be formed by a plane mirror as several distinct properties. It is the same size as the object, it appears as far beyond the mirror as the object actually is, and it is virtual, meaning it cannot be captured on the screen. So it is literally inverted, meaning left and right appear reversed, and the line joining any point on the object to the corresponding point on the image crosses the mirror at a right angle. In contrast, a real image is one that can actually be formed on the screen, as seen in devices like a film camera and a movie projector. So refraction itself can happen in two different ways depending on the surface involved. So we have regular refraction, also called specular refraction, when occurs when a set of parallel light rays strike a smooth, flat, polished surface, such as a mirror, and the refracted rays remain parallel to each other. Since the normal is the same at every point on such a smooth surface, parallel incidence produce parallel reflected rays, which is exactly how the clear image you see in a mirror is formed. So diffuse refraction, on the other hand, occurs when a set of parallel lights strike an irregular surface, such as a piece of paper or a rough concrete path. Because each point on such a surface has a different normal, the angle of the incidence is different at each point, and so according to the law of refraction, each angle of refraction is also different, scattering the rays in many directions. So this diffuse refraction is actually the same reason we are able to see most of the ordinary objects around us that are not sources of light themselves. So even though a clear image can only be formed on a smooth surface. Now let's move on from refraction to refraction. So by definition, refraction is the bending of light rays as they pass from one medium into another. It happens at the boundary between the two media caused by the fact that light travels at different speeds in different substances, such as with refraction. Refraction has its own two key terms. So number one was the normal. In this case, just simply the line drawn at right angles to the boundary between the two media. So we also have the incident ray, which is the ray that falls on that boundary, and the refracted ray is simply the path the light follows after it has been refracted. So the angle of incidence is the angle between the incident ray and the normal, and the angle of refraction is simply the angle between the refracted ray and the normal. So the emergent ray is simply the path followed by the light as it comes back out of the medium, such as a glass block. Alright, so there are three important patterns that describe how light behaves as it moves between media of different density. So when light travels from a less denser medium into a denser one, it is refracted towards the normal, and its speed in the denser medium becomes slower than its speed when it is in a less dense medium. So when light travels from a denser medium into a less denser one, the opposite happens. It is refracted away from the normal, and its speed becomes faster than it was in the denser medium. And when light enters another medium exactly at right angles to the boundary, not bent at all, even though its speed still changes depending on the medium it enters. So these behaviors are described precisely by the laws of refraction. So the first law simply states that the first law is rather known as Snell's law, which states that the ratio of the sine or the angle of incidence to the sine of angle of refraction is a constant for a given pair of media, and this constant is called refractive index. And some typical refractive index values are worth remembering. For example, like for water has 1.3, glass has 1.52, and the diamond has 2.42. Then the second law in refraction simply states that the incident ray, the refracted ray, and the normal ray all lie in the same plane. Alright, so refraction also explains the phenomenon you may have noticed yourself. For example, when your objects are immersed in water, such as a coin at the bottom of the bucket or a fish in a pond, it appears to be near to the surface than they truly are. So this happens because light from the object is refracted as it leaves the water and reaches the observer's eye, making the object appear to be at a shallower position than its real depth. So this relationship gives us refractive index expressed as the ratio of the real depth to the apparent depth, and the apparent depth is always less than the true depth of the object. This is the very same reason why swimming pools and ponds always look shallower than they actually are. Okay, so close related to refraction is the idea of the critical angle. So the critical angle, by definition, is the angle or the incidence at which the angle of refraction becomes exactly 90 degrees. So beyond this angle, the light no longer reflects out of the medium at all. Instead, it reflects entirely back inside it. So typically, critical angles values are worth remembering as well. That's the critical angle for water is 49 degrees, for glass is 42 degrees, and for diamond is 24 degrees. Alright, now let's move on to lenses. So we need to define what a lens is. So a lens is a piece of glass or any other transparent material that has heavy surfaces, and there are too many types of lenses. So a convex lens is also called a converging lenses. It's thicker in the middle than at the edges, and it also converges or draws together right rays to a point. So a concave lens, also called a divergent lens, is a thinner in the middle and than at the edges, and it also diverges or spreads out light rays instead. So there are a few important terms used to describe a lens. So we have what we call the focal point, also called the principal focus. It's the point at which light rays either converge to or appear to diverge from. And every lens has two focal points, one on either side. So the optical center is simply the center point of the lenses. The principal axis is the line that passes through the optical center and is perpendicular to the plane of the lenses, and the focal length is the distance between the optical center and the focal point. When converging lenses forms an image, that image can either be real or virtual. So a real image is one that can actually be formed on a screen and can be seen clearly. It must be properly focused by the moving screen near to or above of the lenses. So a real image is always upside down. It can be magnified, it can be diminished, and the same size as the object. It always forms on the opposite side of the lens from the object. While a virtual image, on the other hand, cannot be produced on the screen at all, and to see it, you must look directly through the lens on the same side as the object. So a virtual image is always upright, always magnified, and always forms on the side of the lenses as well. So to understand exactly where and how these images form, we use the ray diagrams, which show the arrangement of the object, the lenses, the light rays, and the resulting image in relation to one another. And from these diagrams, we can tell whether an image is real or virtual, magnified or diminished, on which side of the lenses it appears. So a close related idea is what we call magnification. So magnification is which is the ratio of the size of the image to the size of the object, and can also be calculated as the ratio of the distance of the image from the lens to the distance of the object from the lens. So magnification has no units, since it's simply a ratio. When magnification equals 1, the image and the object are the same size. And when it is greater than 1, the image is larger than the object. And when it is less than 1, the image is smaller than what? The object. So when drawing a ray diagram through a lenses, there are 3 simple rules you need to remember. So the first rule is that rays traveling parallel to the principal axis are refracted through the focal point. Rays passing through the focal point are refracted so that they travel parallel to the principal axis after passing through the lenses. And rays passing through the optical center continue in a straight line without bending. So to locate an image using a ray diagram, only 2 of these 3 rules are actually needed. So you simply find the point where the refracted rays intersect, and that intersection gives you the position of the image if refracted rays themselves intersect at a point. So the image is real. If instead the rays only appear to intersect when extended backward behind the object, the image is what? Virtual. And if the refracted rays never intersect at all, the image is said to be what? Formed at infinity. So the exact position of the object relative to the lens determines what kind of image is formed by a convex lens. So there are 6 key positions worth knowing. So when the object is placed beyond twice the focal length, known as 2f, the image forms between f and 2f. On the other side, it is real, inverted, and diminished. When the object is placed exactly at 2f, the image also forms at 2f, and it is real, embedded, and the same size as the object. When the object is placed between 2f and f, the image forms beyond 2f, and it is real, inverted, and magnified. When the object is placed between f and the optical center, the image forms between f and 2f on the same side as the object. It is virtual, upright, magnified. Then the object is placed exactly at f. The image forms at infinity. And when the object is placed at infinity itself, meaning the incoming rays are parallel, the image forms exactly at f, and it is real, inverted, and diminished. Alright, now let's start our exam practice. Alright, so the question reads, Figure 7.1 shows a ray of light through semicircular glass block. The incident ray, I, strikes the center C at an angle theta. The angle is gradually what? Increased. Alright, so question 7A1, or question 7 rather, reads, describe the variation of the A1 intensity of the transmitted ray T as angle theta gradually increases. So the answer there is that the intensity of the transmitted ray T decreases as the angle increases. Then moving on to question A2. Question A2 reads, intensity of the reflected ray R as angle theta increases. So the answer there is that the intensity of the reflected ray R increases as angle theta increases. Moving on to question B1, question 7B1, it reads, the transmitted ray T is displaced in two different colors. Which colored light would appear first as the angle increases? So the answer is what? Violet light would appear first. Alright, now moving on to question 7B2. Question 7B2 reads, suggest whether or not there is any deception of colors for emergent ray E and explain your answer. So the explanation is simple. It's just that the straightforward answer is no. Reason, because there is no deception of colors from the emergent ray E, because the ray emerges from the curved surface along the normal at E, so no reflection occurs there. So one or two things. Please do join our online tuitions if you want to improve your grades and your grades, yeah. Then do also buy our PDFs. We're also selling PDFs there at only 5 kwacha. We're also selling lesson videos at only 10 kwacha. We're also advertising on our channel. If you have a business or you want to start a business, you can WhatsApp me on the number showing on the screen there. Then you can make an arrangement where you advertise your business here, regardless of the size of the business. Then if you want to make money while you are teaching or while you're explaining what you know in school or what you are learning currently in school, and you want to make money of that, you can just simply WhatsApp me on the number there so that you join the Mutale TV tutor network, whereby you get the 95% of revenue coming from your class and your students. Then Mutale TV on guess what? 5%. Alright, thank you for watching. This was Robert Mutale presenter. Bye bye.